Welcome back, welcome back. Today we're going to talk about spheres. And the thing about a sphere that you have to remember is a sphere is a ball. And so it has a center, but every point around that sphere is equidistant from that center. And so when I draw a 3D image of this sphere, I can divide it in half, kind of like the Earth has the equator. This circle around the middle is called the Great Circle, because it can't get any bigger than that. It's what divides the sphere into two hemispheres. Divides sphere into two hemispheres. And hemispheres are just half of the circle, or half of the sphere. And so hemisphere equals 1/2 of a sphere. Okay, so it's half of a sphere. Other things we need to talk about in conjunction with spheres. This here is called the radius. It goes from the center to the outside. And also we need to talk about the volume and the surface area of this sphere. We have formulas for these as well. And the volume of a sphere is equal to 4/3 times pi times radius cubed. So in this case the radius is going to be cubed because it's having to do with 3 dimensions and the volume. The surface area of a sphere is going to be in a radius squared, so the surface area equals 4 times pi times radius squared. Okay, so we have two formulas here that have to do with these spheres. We're going to find the indicated measurements. We're going to find the volume and the surface area of this sphere, which has a radius of 9. So R equals 9. So when I go to find the radius, or when I go to find the volume, 4/3 times pi times radius cubed equals 4/3 pi times, and now radius cubed, so that's 9 to the 3rd power, 729, and watch how I do this. So I've got 729 times 4 over 3 times pi. So I'll divide that by 3. And that gives me 972 pi meters cubed. Okay? Leave it in terms of pi because we are once again dealing with a circular type object. Surface area equals 4 times pi times radius squared. Not as difficult this time. 4 times pi times 81. And if I do 81 times 4, you can probably do that in your head if you're good. And that's 324 pi meters squared. Okay, that's all there is to it. So we're taking these measurements and we're plugging them into this formula. Now, the problem is when they give us something that's not just the straight up measurement, not just the radius, and they give us something that we have to solve for something else. Well, we know about this stuff already. We already know how to solve formulas to find the measurements that we want. And so if I'm going to be finding the volume of the sphere in letter B here, I know it's going to be 4/3 pi times radius cubed. Well, the problem is they've given me the surface area and I don't have the radius. So I know that surface area equals 144 pi, and I know that the surface area is 4 times pi times radius squared, and that's equal to 144 pi. As I've done before, I'm setting the formula for that surface area equal to what it actually is, and I'm going to solve for what I don't know. Well, in this case, here's what I want to find. I want to find the radius. Well, I need to eliminate all this stuff, so I'm going to divide by 4 pi on both sides, and we're going to look to see what happens here. So this all goes away, and I have r squared is equal to, the pi's cancel out, and 144 divided by 4 is 36. So my radius is equal to 6. Now, not done yet because I really want the volume, and I found the radius. So now I can plug it into my volume formula. 4/3 pi times 6 cubed. Well, I don't know about you. I don't really know what 6 cubed is in my head, so I'm going to go 6 to the 3rd power. and that's 4/3 pi times 216. And I can do something like this, rearrange it, because multiplication is commutative, meaning the order doesn't necessarily matter for the problem. So 4 times 216 over 3 times pi. And if I do 216 times 4 and divide by 3, I get 288 pi. Okay? So that's 288 pi, and it's meters squared, so this is meters, and volume is in cube units, so it's going to be meters cubed. Alright, so I used a formula to solve for a measurement and then plug that measurement back into a different formula. It's really just kind of a system here, guys. Okay, so let's see if we can do C and what we get. The surface area of a sphere with a great circle that has an area of 4 pi inches squared. Well, if you remember the great circle here, the great circle is the circumference of the middle of that thing. Okay, so if I have the area of it, remember the great circle is divided, is a measurement that's based on the radius. Okay, so the great circle goes around the middle of that sphere. And so if I can find the radius of the great circle, that's the radius of the sphere, because it goes around the middle. Area of great circle equals pi times radius squared, because it's just a circle. So pi times radius squared is equal to 4 pi. And I think you'll see what happens here pretty quickly. Radius squared equals 4, which means radius equals 2. Now, surface area, I have the radius, so if I look up here, take a little peek, 4 pi r squared. So, surface area equals 4 pi times radius squared equals 4 pi 4, that's multiplication, equals 16 pi. My units are inches, inches squared, because it's surface area. That's all there is to it, guys. We're taking these formulas, breaking them down, finding what we want, and plugging it back in. That's all there is to it. Thanks for watching. We'll see you next time.